Hello students, today in 11th class I will teach the 12th chapter called the Thermodynamics, Ushma Gatiki, Thermodynamics. Thermodynamics. In the previous chapter, you studied about the thermostatics. In thermostatics, the heat energy remains constant, and this is not transferred in any other kind of energies. But in thermodynamics, we study that the heat energy is converted into another forms of energy. In thermodynamics, the heat energy is transformed in other forms of energy. So the transformation of heat energy is studied in thermodynamics. This is what the meaning of thermodynamics. In thermostatics, you saw that the heat energy is given, then there is the change in temperature, and it is not being changed into the another form of energies. So there is a change of state, there is change, there is a specific heat, latent heat. All this is the thermostatics. In this, the heat energy is not converted into other forms of energy, but in this thermodynamics, the heat energy is converted into other forms of energy that you will see in the different topics here. So let us first say that when the transformation of heat takes place, then there must be a good exchange of energy and the matter with the other systems. So first we will find that what is the meaning of a thermodynamic system and what is the surroundings. Thermodynamic system. When the matter is confined by certain boundaries, it is called thermodynamic system. The system may exchange heat, matter, or both. Heat and matter. So on this basis the systems are of three kinds. Now we will take the surroundings. Surroundings means the medium around the system. With which exchange of heat or matter takes place. Is called surroundings. Suppose we are in this room, then this room is the system. All the bodies kept in this room. This is the matter, and the medium around this room is called the surroundings. So the system may exchange the heat or the matter with the surroundings. Whatever medium is present around the system, that is called the surroundings. And with these surroundings, there is the exchange of heat or matter or both. Kinds of systems. There are three kinds. One is open system. Open system is when exchange of heat and energy, heat and matter takes place between system and surroundings. It is called open system. Suppose you have a room and everything in the room is the matter. Here is the gas, the atmospheric air, and when the windows and these doors are opened, then the air go and come inside the room. So the exchange of matter and then the heat also is regulated by the flow of the air. That is the open system. Number 2, closed system. When there is exchange of heat between system and surroundings. It is called closed system. Closed system does not exchange matter. So this is the closed system. In number 3, isolated system. When there is no exchange of heat and matter, with the surroundings, the system is called isolated system. When there is no exchange of heat and matter with the surroundings, the system is called isolated system. In such systems, the pressure, temperature and volume are remains constant, and this is the heat is neither given nor taken, and matter is also neither taken nor given to the surroundings. Then this is called the isolated system. And here in this branch of physics, we will study only about the closed system in which the heat is exchanged with the surroundings. Now we will take the thermal coordinates. Thermodynamic coordinates. The pressure, P, volume V, temperature T, enthalpy, entropy, etc. are called thermodynamic coordinates. But here we will confine ourselves only up to the pressure, volume and temperature. Here we confine ourselves only for pressure, volume and temperature. So this volume, this pressure, volume and temperature, these are called the thermodynamic coordinates. These are called thermodynamic coordinates. So these coordinates always describe the state, equation of the state of the thermodynamic system. Because you have seen that in coordinates we have the x, y, z. That is called the Cartesian coordinates. And the Cartesian coordinates always describe the position of a particle in x, y, z system. So similarly here, in thermodynamic system, we say that this is the parameters pressure, volume and temperature that describe the equation of state of the system. So now I will tell you the equation of state of the system. The thermodynamic coordinates describe the states of system. So now equation of states. The relation among pressure, volume and temperature is called equation of state. Generally, function of pressure, volume and temperature is equal to 0. This is the general equation of state. It is general equation of state. Now we can give the example of this one. PV equal to RT. This is the gasification. And then P plus A upon V square into V minus V equal to RT. Van der Waals equation. Van der Waals equation. This is called like this equation like this. They are called the equation of state of the system. They always describe the relationship between pressure, volume and the temperature. This is called the equation of state. Now we will take the thermodynamic equilibrium. When a system have constant pressure, volume and temperature, it is called in thermodynamic equilibrium. So all three parameters, pressure, volume and temperature, are constant of a system, then it is called the thermodynamic equilibrium. So equilibriums are of three kinds. Kinds of equilibrium. Number one, mechanical equilibrium. Mechanical equilibrium means that no force must act on the system. So no force when no force acts on the system, it is called mechanical equilibrium. It means that summation F, this must be equal to 0. Moreover, the internal forces, like the one part of the system, must not apply the force on the other part of the system. So internal forces must also be the 0. The internal force is equal to 0 does not mean that there will be no molecular force between the molecules of the system. But this only means that the one part of the system will not apply a force on the other part of the system. Then this will be, and also that no external force will be applied on the system. Then it is called in mechanical equilibrium. And number 2, chemical equilibrium. Chemical equilibrium is when the chemical composition of the system is constant. When chemical composition of system. Does not change. It is called chemical equilibrium. And now third, thermal equilibrium. Thermal equilibrium means that the temperature of the system and surroundings are the same. Then it is called thermal equilibrium. When temperature of system and surroundings are equal, it is called in thermal equilibrium. So temperature is same is the exchange of heat will be taken in the same amount. So the both of the surrounding and the system must have the same temperature. So this is called the thermal equilibrium. So when all these three equilibriums are attained by the system, then this is called the thermodynamic equilibrium. When system is in mechanical chemical and thermal equilibrium, it is called thermodynamic equilibrium. So whenever we say that system is in thermodynamic equilibrium, means that the system is in mechanical equilibrium, it is in chemical equilibrium, it is in the thermal equilibrium. So when all these three kinds of equilibriums are attained by the system, then this is said to be in thermodynamic equilibrium. So these are some definitions which are very important to understand the thermodynamics. And after this, that you will study so many physical quantities related with the thermodynamics. So there will be the zeroth law, first law and the second law of thermodynamics. So these are very important to understand the thermodynamics. These are some definitions which are usually used in thermodynamics. So you like, share and subscribe this video. Thank you.